So what we're going to do here is some sample limit problems. So we're using the second column because you all will be doing the first column pretty much for homework. So here we go. So we're using the limit problem sheet and B through J. Okay. So first one, just so you can see not only how to do them, but also how to structure them, what the work looks like. So our problem here is the limit as x approaches -1 of x to the third plus 2x squared minus 3x minus 4, right? So standard of work is also really important as well so that we understand what is required. So the first thing I'm going to do here is, as we always do, we hope a simple plugin will work, right? So here we go. I'm just going to show that plugin, right? Actually show the plugin, not just a number. So -3, -1, -4, and that's going to work. So we're going to get an answer out of this. You could skip the step that I'm doing right now. I just I'm doing the math in my head, so I like seeing it out. And so my answer then is 0, apparently. How interesting. Right, so the limit as x approaches -1 of that trinomial expression is 0. So 1d, then the limit as x approaches 2 of x minus 1 over x squared minus 1. Well, this function here potentially has a place where this is undefined, but we're not dealing with it at the undefined point. So we're just going to plug in and find out that our answer then is going to be 1 over 3, and there you go. Box my answer, box my answer. Okay, so 1f, we've got the limit as x approaches 2 of x squared minus 4 over x squared minus 5x plus 6. And so here we go. If I do my plug-in, I get 2 squared minus 4, 2 squared minus 2 times 2 plus 6, right? 5 times 6 rather, excuse me, 5 times 2 plus 6, which gives me 0 over 4, and this is 0, 0, I got an indeterminate form, and so I'm looking at this thing and I say to myself, the first thing I'm going to do here is to factor, because I don't want to go to my last resort of the numerical evaluation unless I have to. And so the hint here is, always use this as one of our factors, because that tends to be the way these things function. So I got to keep the limit operation down in my factoring because I haven't taken the limit yet. We know the top is x plus 2 and x minus 2. So I'm going to guess the x minus 2, which is the thing that gives us our indeterminate form, is the issue. So if that's the factor, clearly x minus 3 is the other factor there. These go away. And now I can just evaluate 2 plus 2 over 2 minus 3. And apparently my answer is -4. Ah, glorious. No numerical evaluation. Everything is right with the world. So I've got the limit as x approaches 2 of x plus 2 and x squared minus 4. If I throw that in, 2 plus 2, 2 squared minus 4, I've got 4 over 0, indeterminate form. Got to do something different. So here we go, limit as x approaches 2. This is clearly a factoring type problem. X plus 2, x minus 2, there we go. Interestingly enough, if we look at this, what goes away here is not the part of this that will be problematic, because I'm going to still end up with an indeterminate form on the bottom. Right? So I'm just looking at that and going, okay, well, let's just numerically evaluate that then, because I know that that's going to come out to another indeterminate form, and I have no other way of reorganizing that. So x and f of x, right? And I don't have to go back to the original expression anyway. I can use this much simpler expression in order to do it. So I need to have 3 things under, so 1.9, 1.95, 1.99, and 3 things over, 2.01, 2.05, and 2.1. So we're going to plug into this expression, which will be identical as using the original expression because of that simplification. So I've got 1 divided by, okay, I've got negative 10, okay, so I've got negative 20, and this is going to be negative 100. This is going to be positive 100. This is going to be positive 20, and this is going to be positive 10. So we can see as we approach 2, this is negative infinity, and as we approach 2 from the right, this is positive infinity, and therefore I can say because the limit as x approaches 2 from the left of f of x is not equal to the limit as x approaches 2 from the right. Therefore, the limit as x approaches 2 of f of x equals d and e. And there you go. And there's a sufficient standard of work for that problem. Right? Now, I will tell you here on these problems, if you see it's going to indeterminate form, right, you don't have to explicitly show that it's going to the indeterminate form. I think it's just a matter of good habit to do it, but it's not a required step. Like if you looked at this and then in your head factored and said, oh God, I still have a problem, and knew that you have to numerically evaluate it, you could have gone right to the numerical evaluation. But once you do the numerical evaluation, this is the standard of work, no less. All right. Great, one more problem. Oh, and here's an interesting one. Look at this. 1j has no numbers in it. Oh, okay. Well, I mean, it has 0 in it, but no one really cares in math about this because we're comfortable with dealing with things that, you know, don't have numbers. Now, if I just evaluate this, right, see what I get. X cubed, or x plus 0 cubed, x cubed over h. It looks like I'm going to get, over 0, excuse me, 0 over 0 in indeterminate form. Therefore, I need to do with this. Now, obviously, I can't numerically evaluate it because I don't have values. I mean, I guess I could put in like, you know, I could numerically evaluate that, but I don't want to. So, I know what I can do. I can transform this by expanding the top. So let's expand the top. So the limit as h approaches 0, and I've got a cubic, so here's the expansion of that, cubed plus 3x squared h plus 3 xh squared plus h cubed minus, this is cubed, excuse me, minus x cubed all over h. Now, I can't plug in still because I'm going to still have that indeterminate form here, but I do notice that I could get rid of my x cubes there. That's neat. So let me just rewrite what I have here. Limit as h approaches 0. And for those of you who are just screaming at me in your heads that you know what this is, we're going to teach it slightly differently soon, but hold on to your horses. All right. Now, here's an interesting thing. I've got an h in every term, so I can actually just factor out an h from each part of the expression. I like to then rewrite it because it makes it look pretty. So I've got the limit as h approaches 0 of 3x squared plus 3xh plus h squared. And of course, hey, look at that. Interestingly enough, this first term has no h in it, so that's going to survive here. So this is going to be 3x squared plus 3x times 0 plus 0 squared, or just 3x squared. So the limit as h approaches 0 of x plus h quantity cubed minus x cubed over h is this expression here. It's another function. Well, that is just delightful and may have some implications in the future.